Hey there, friends. Today we're talking about Math 105, Section 2.3, and we're going to deal with piecewise functions. And, I'd like to say that piecewise functions for a lot of people leave a little bit of sick in their mouths, but I don't think they're that terrible at all. And a piecewise function, all it is it gives us different rules that depend on the domain. So that's it. That's all we're playing with. So imagine the most beautiful of wives earns $30 per hour for the first 40 hours worked. At which point, after 40 hours, she earns $45 per hour. And that, my friends, is called time and a half, which is almost as nice as double time. But we won't talk about that today. So we have two different rules here. For the first 40 hours, we're going to earn $30 per hour. And so I don't think that's hard. I'm going to call it R1 for the first rule. And so, sure, we're going to have 30 times t. That's a linear function. And what I'm going to tell us is that R1, this first rule, it's only valid from 0 to t to 40. Now, for my second part of the rule, I'm going to have to be a little bit clever because what I've really done, and maybe I'll make a sketch over here of what's happened. The most beautiful of wives, she went out and earned, and that's going to be the point 40 comma something. And then 40 times 30 is going to be $1,200. I love it so much. But at this point, note that the slope here was 30. Now the slope is arguably going to be bigger. The slope is 45. And so I'm going to use point slope form to make that equation. Point slope form, for those of you in the cheap seats, is y is equal to y naught plus m times x minus x naught, where we have x naught, y naught right there, and that is our slope. So our second rule is going to be 45 t minus 40 plus that 1,200. I'm sorry, I wrote it in the wrong order, but it doesn't really matter. This rule carries over from 40 hours and onward. Now, technically speaking, these two lines, they do touch at this point, and so I could have equality at both, but I prefer not to, because what if I had something like this, where I had one line that was solid, and then I had another point? It would not be a function. So in order to avoid that, I typically, even if I have things that meet, I have one of them open, and I have one of them closed, and in this case, it wouldn't matter which. Let's wrap this in a tux, please. Let's call this W equals f of t. That's the most beautiful of wives' wages, is a function of t. And this is how we put the piecewise function together. We use a large curly brace, and usually I use the first part of the domain, but we'll have 30t. And when is that valid? From 0 less than or equal to t less than or equal to 40. And then 45 t minus 40 plus 1,200. And that's valid for 40 less than t. And so this, my friends, is how we represent a piecewise function. Not a big deal. I think we'll do one more example and call it a day. Well, friends of mathematics, we're finishing up piecewise functions, and I have a new piecewise function for us. And this piecewise function, y is equal to p of x, and I have three different rules. And the first rule is x squared, and that's valid from -5, not included, to 0 included. The next rule is 2, and that's valid from 0 to 2. The next rule is 3 times the quantity x minus 2 plus 2 from 2 to some number. Actually, I'm going to give us one more rule. I'm going to put one more in here. Let's say less than 3. And you know what? I'm just going to put one last one. I'm going to say 10. And that final rule will be valid when x equals 4. And let's graph this thing together. So we have some set of axes. I always like to label them. Mind you, the label here is not p, it's y, our output variable. And the first thing we'll do is we'll say, okay, I've got to have this goofy doodad here. Now, from -5, so we can just kind of go, here's -5. And what's going to happen is I'm going to square that thing. Oh my goodness, look at this. I'm going to have to draw over my function. Well, so be it. So 25, so 5 comma 25. And we have that point right there. And we know that x squared, how it behaves, it comes down, it's a quadratic. And when I put 0 in, we're going to have 0. Oh, now I made a mistake. Because at -5, it's not included, so it should be a whole. But at 0, it is included, and so we're going to have a dot. And we finished up our first rule. Now, our second rule is 2. So y equals 2, and that's a horizontal line. And it's going to start at 0. So if that's 25, then 2, my goodness, might be right there. Yeah? And it's going to go until x is equal to 2. And that's going to be a solid dot there because we have equality. So our third rule, we have 3 times the quantity x minus 2 plus 2. And that's going from 2 not included to 3. So when I put 2 into this function, I know I really can't, but that's just an imposition from this domain. So when I put 2 in, notice that murder is going to occur here, and we're going to be at the point 2, 2, exactly where we were. So even though there's a hole, it's just going to be connected, right? So it's just going to be going, and then the slope is 3. And so when I put 3 in, we'll have a 1, and so we will be at 5. So we're going to have, once again, a hole like that. And I'm even going to put the coordinate because I'm a little bit out of scale here. So we'll say 3 comma 5. The final thing is we have this other point that I put. Oh, and we're going to 4. So when x is 4, we hit 10. And that, my friends, is the graphing of a piecewise function. One last thing that we can talk about here is the domain and the range. And the domain are all the possible inputs. And you can see that I'm using everything, but I'm not using 5. So -5 is not included. I'm going to 0. I'm using 0. Even though I'm not using it on this function, it's included in the domain. I'm using everything until +3. I've used everything from this point not included to that point not included. And now I have to union that with that single value of 4. We also can think about the range. And the range, we're starting from the smallest value and going up to the largest one. And so the smallest output, the smallest y value we have is 0, and that 0 is included. And then we begin to go up, and even though I'm not using 2 here, I'm using 2 over here and over there. Even though I'm not using 5, I'm using it over here. So I'm including all of these values. Here, I don't have to list that I'm using 10 twice. And even though there's a gap in between these outputs, I'm using all of the outputs there. And the final output is 25, which is not included. If I wanted to write this in inequality notation, I could say that the domain is -5 is less than x, which is in turn less than 3, or x is equal to 4. If I was going to talk about the range, I would say that 0 is less than or equal to y, which is less than 25. Note that when we talk about our piecewise functions, the convention is to use inequality notation on the rules as we've written them.